You go to open the door to the new cafe in town, only to realize you've pushed on the side with the hinges, and it doesn't open. That's almost as bad as pushing on a pull door. How embarrassing. But don't worry, we've all been there. Why can't you open the door on the hinge side anyway? It's not like the weight of the door is smushed next to the hinges. This comes down to the idea of torque. To have torque, we need a pivot point. Conveniently, most doors come with a pivot point. They're hinges. So, what exactly is torque? Torque is a force that determines how much something rotates. If we have a large torque, we have a large rotation, which means the door opens easier. For the scope of this video, torque comes from two things. First, imagine you put your hand against the door like you're ready to push. The distance from the hinges to your hand is our first measurement. The second is simply how much force you put into your push. Here's the actual equation. We represent that distance with R, and we represent your force as F. Then we multiply them together. There's this sneaky little sine theta, but don't be scared off by it. This basically just means you'll have an easier time opening the door how you normally would, instead of trying to push the door toward its hinges. For the most part, we can just ignore the sine theta. Now, a certain amount of torque, mostly determined by the weight of the door, is needed to open it. So, we have to reach this magic number. Say, for example, we need 12 Newton meters to open a door. This Newton meters, or Nm, isn't significant except for the physics students out there who need to put units on their answers. If the door is 4 meters wide and we push right at the far edge of the door, then we need a 3 Newton push to open it. If we move closer to the hinges, so we are now 2 meters away, we need a 6 Newton push to open it. This is twice as much strength as it took before. This is because we still need torque to equal 12 Newton meters. As you can predict, if we move closer, say 1 meter away from the hinges, now it takes 12 newtons of push to open the door. At a certain point close to the hinges, your own strength won't be enough to open the door, and if you somehow come up with a strong enough force, you're more likely to just break the hinges and have to deal with the manager who is pretty mad you just broke her new door.